A square charge configuration with sides a meter have charges Q1 equal to Q, Q2 equal to 2Q, Q3 equal to 6Q, Q4 equal to 8Q at the four corners, and a charge Q at the center of the square, full stop. Starting with charge Q1 at the top left hand corner and moving clockwise direction, show that the net force on charge Q due to the other charges is this. We said FQR is equal to root 2 into KQQ all over A squared into I plus 11J all in Newton to show this. Alright, that's what they said square. So get your square. I'm having this. Get the big square. I'm assuming this to be a square. Alright, so get the square, that's 1. Next they said Q1, Q2, Q3, Q4. They said at the four corners, starting with charge Q1, so Q1 at the top left hand corner. So here's my left, top left becomes here. So I'm having Q1. They said I'm moving in a clockwise direction. Clockwise is this way. So it becomes Q1. Next up is Q2. Next up, Q3. Next up, Q4. I have this. Okay. All of these have their value. Let's keep it plain for now. Next up says you have Q at the center of the square. So perhaps this, you have this, and then this. So at this point, I have a charge Q here. I have a charge Q here at the center of the square. Distance here is what there? A meters. Yes. A meters. Yes. A meters. Yes. A meters. My first task will now be, of course, I know that I'm moving this way, or perhaps let's go straight. From here, we know that the resultant force on this one here, that's FQ resultant. FQ resultant is equal to the sum of the force between this. That should be FQ1 plus FQ2 plus FQ3 plus FQ4. Alright, for each of them I have FQ1, FQ2, FQ3, FQ4. So I have to find each of them individually. Let's start with FQ1. So from Coulomb's law, we know that FQ1 is equal to KQ Q1 all over RQ1, this one there, all squared dot unit vector of RQ1. So I have this. Alright, first task, this one here. Let me get the position vector of RQ1. That will now be equal to RQ minus R1. R1. Of course, this one here becomes your reference. So it's 0 minus, let's get R1. So R1 I'm moving to, here's my reference. I'm moving from this Q chart to R1 here. So I have to move from here, move this way and this way. Now question, if from here to here is A, then this becomes what there? A over 2, I mean? Yes. Right, so from here to here becomes A over 2. This is 9. So A over 2. From here to here is A over 2. Next up, if from here to here is a square, is A. Then from here to here becomes what there? Still A over 2. I mean? Yes. From here to here This is A, so half becomes half of A, that's A over 2. Same thing here, from here to here is A. So that means from here to here becomes also what there? Half. That's A over 2, so we have this. So make your movement from here. This is going from here, it's going left this way. Distance here is A over 2. It's going to the left, so it becomes what there? Minus. So it becomes minus A over 2. In what direction there? The I direction. So from here to here. Next up, from here I'm going upwards. So it's going upwards. That becomes what there? Positive. Distance from here to here becomes what there? A over 2. So it becomes A over 2J. That becomes your position. So minus A over 2I plus A over 2J. So I have this. Work this out. This is equal to minus minus is plus. It becomes A over 2 I. You are given A meters, are they? Should you add meters here? No. Is it necessary? It's not necessary now. You can leave it there. Okay, so A over 2I minus plus minus A over 2 what there? G. So I have this as RQ1. Just for the tape. This is in meters. This one takes in meters. So I have this. What next? We said next is what there? Magnitude. So get the magnitude of RQ1. For magnitude, we said to get magnitude, take the square root of each of the terms squared. So it becomes the square root of this term A over 2 all squared plus this term, this is minus A over 2 also squared. Alright, work this out. This is equal to, I'm having this as the square root of, this gives you A squared all over 4 plus minus A all squared gives you what there? Positive. Becomes A squared all over 4. So I have this. Work this out. This is equal to, I'm having the square root of, if I add this 2, it becomes common denominator. I mean, 4. A squared gives you what there? 2A squared. So I have this. Obviously from here, this here 1, this here 2. So I have this to be equal to the square root of A squared all over what there? 2. I have this. Can it be simplified? Obviously, from the idea of indices, square root will affect both here and there. So it becomes the square root of A squared all over root 2. So this to this, this to this. From here, square root cancel square is equal to what there? A all over root 2. So this now becomes the magnitude of RQ1. You have this. We're not done yet. And next task to find unit vector. So the unit vector of RQ1 is equal to, we said is equal to position vector all over magnitude. So it becomes position vector of RQ1 all over the magnitude of RQ1. I have this. And that's now equal to position vector of RQ1 was this. So it becomes A all over 2I minus A all over 2J. That's this. You can choose to put meters and put meter here. Still fine. Of course, this all in meters, as we said. All over, I'm having this A all over root 2 in meters. You can see. So meters cancel meters. That's why I said it's not that compulsory. But just for test sake, put the meters. But of course, we'll cancel out. So we have this one here. My task now is simplifying this thing here. How do you simplify this? We said take them individually. So this is now equal to, let me make it easier. These two are common, so they can be factorized. Are they? Yes, they are common, so they can be factorized. Factorize a over 2. I have what there? A over 2 into what there? I minus j. Alright, so factorize this one here. All over this one here. A all over root 2. So I have this. Let's try this one here in layman's form. Just for explanation purposes there. After I'll skip it. But look at this. This will be equal to, we are saying this one here, a all over 2 into I minus j divided by, so divided by this one here, a all over what there, root 2. So I have this. So divided by a over 2. So what do I get here? For when you're dividing fraction, we said change the word there, times, we change division to multiplication and we invert. This is now equal to a over 2 into I minus j. Here becomes times and inverting root 2 all over there, a. So change that to times and then invert. From here, a cancels a, so it's up. Bring this one to the front here. I will have that the unit vector of arrow q1 is equal to, bring this one here, becomes root 2 all over 2 into I minus j. Alright. Root 2 all over 2 I minus j. So I have this one. Any questions? Any questions? Next up. Substitute. What do you get? So we said that f q1 is equal to k q1 all over r q1 this all squared dot unit vector of r q1. Right. Let's substitute. This is now equal to, I'm having k, okay, I'm having q. Please check. In the question, what was q1 there? Q was q, I mean? Yeah, so this becomes q. All over, check. What was the magnitude again? Check. What's the magnitude? A over root 2. It becomes a all over what there? Root 2 as your magnitude. All squared, yeah? Dot unit vector, which is this, that becomes root 2 all over 2 into I minus j. That's it. Becomes this, so q1 was equal to q. This value was this, all squared dot, this value is what you have there, and I'm having this. Simplify this one first. This will now be equal to, I have k, q, q, all over, this and this gives you a squared, all over, let's save time, square cancel square root, I mean? So it gives you what there? 2. Let's save time please. So this and this, a squared. Here, I'm squaring the square root. It will cancel out. Dot, what do I have here? Root 2 all over 2 into what there? I minus j. Let's see how we can work this up. Let's see how we work this up please. To save time, look at this. To save time, look at this. See, look at this. If I have if I have this a all over b over c, this will be equal to a divided by b over c. To solve this one here, I will change here the times and I will invert. So it becomes what there? C over b. This is now equal to a times c is ac all over what there? B. So if I'm having a term in this form, something all over this, the simple idea is multiply these two. So it becomes a times c all over b. That's what you have here. Use this concept here. The same thing works here. That means it becomes this times this one here all over this. So if I solve this, it will be equal to this times this gives you 2 times this gives you 2k into q, alright, all over this one here, that's a squared dot, I have this root 2 all over 2 into I minus j. From here, obviously, this can cancel this, so it's off. Next up, bring this one here. That's now equal to this and this. That means I have that f q1 is equal to, this man comes here, becomes root 2 into k into q all over, I have a squared into I minus j. So I have this. If you look at what we asked to prove, this looks like that form. I've gotten root 2, I've gotten a squared. So I'm hoping that somehow, this one can cancel out. So I have it. So this now becomes fq1. Let's get fq2. So we've gotten fq1. Let's get fq2. So we have that fq2 is equal to q2 all over rq2, this all squared dot unit vector of rq2. Obviously, starting with this, so I'll have that rq2 is equal to rq minus r2, and that's now equal to, here's my reference, it becomes 0 minus r2. So here's my task, here's 0, r2 is here, so I have to move this way and this way. This distance we said is a over 2, that's half of this, it becomes a over 2I, and go to the positive direction, it becomes plus. So I'm having a over 2 meters I, so a over 2I, of course in meters. Then from here I'm going upwards, still positive, it becomes plus a over 2j, all in meters. Work this out, this is now equal to minus here, minus a over 2I, minus here, minus a over 2j, all in meters. This is the value of rq2. Next up, get magnitude. The magnitude of rq2 is equal to the square root of this squared, a over 2 all squared plus, minus, so minus a over 2 squared plus minus a over 2 squared. This one here will give you what? The same answer as the other one there, of course. So let's save ourselves the stress. That means rq2, please, for that one, what was the answer? A over 2. You have the same answer. Do the analysis. This will now give you a squared. So this square will cancel the minus. It will now be a squared over 4. A squared over 4, same thing. So let's pass the stress. So I have this one here. Let's now get unit vector. Unit vector of rq2 is equal to position vector of rq2 all over magnitude of rq2. I'm having this. That's equal to, position vector is this one here. That becomes minus a over 2, of course meters, a over 2I minus a over 2j, all in meters. I have this. This one divides the magnitude, sorry, this was magnitude, that's this, right. Divides magnitude a all over root 2 in meters 2. So this cancels this and it's off. This is now equal to, we said factorize minus 5. Factorize a over 2 outside, give out the minus. Listen, we know that minus is also common here, but the idea is this: since this is vector and minus connotes direction more, so I'll leave the minus with I instead. So factorize out a over 2. If I take out a over 2, here it becomes a over 2. Here I'm left with minus I, becomes minus I Same thing here. If I take out a over 2, I'm left with minus j. It becomes minus I minus j. This all over what there? A all over what there? Root 2. So I have this one here. Right. We did this before, Abi. We did this also before. Abi? Yes. So we got RQ2. Please check. All this ratio, what was our value? Was it root 2 over 2? Something like that? Right. So we did this before. So I was saying myself that stress. This one here, as we did before, give us root 2 all over 2 into what there? Minus I minus j. So please pick out the point. Right? These two, as we did previously, gave us, so it gives us the same thing there. And that's it. Alright, let's substitute. So substituting, what do I get? I'll get that Q2, I'll get that Q2 is equal to K, that's K, Q. Please check from the question, what's Q2? 2Q. Alright, so we got 2Q, I have this. So please, KQ, Q2 was 2Q, all over magnitude, which is this. That becomes A all over root 2 all squared dot unit vector, which is this. That gives us root 2 all over 2 into minus I minus j. So we have this. Alright, so what can we cast out here? Yes. It's capital Q. So this Q is equal to 2 capital Q. Capital Q. I have this. Alright, work this out. What do you get here? So from here, I have that FQ2 is equal to, now check this out, I have K, okay, let's bring 2 first. So I have 2K QQ all over, this becomes A squared all over, I'm adding this as what there? 2. Right. This is A squared. The square will cancel square root, so it becomes 2 dot. I'm having root 2 all over 2 into minus I minus j. So work this out. How do we solve this? Obviously, this one here will cancel this. It's off. And it's mathematically correct. Next up, we said for this one here, these two will switch. So it's now equal to, set these two will switch. So 2 comes here becomes 2K QQ all over A squared dot root 2 into minus I minus j. Of course, this one comes from here. That's now equal to, now listen to this. Listen. Get the facts here. In my form, listen in my form, what I had there, what I was asked to prove was that what was here, check, was root 2 KQQ all over this. So in this one I have 2 here. The idea will now be this. Move 2 to this one here and bring root 2 here instead. So this now becomes root 2 into KQQ all over A squared. So move 2 to this. It now becomes what there? Minus 2I minus 2j. Please, this stuff is actually very intentional, please. In my form, I had root 2 KQQ over Q squared. So my task will be to present this form. In trying to present this form here, I'll bring this one here. I'll take this one this way. So it becomes root 2, it becomes 2 times this one here, such that if I expand, it becomes 2I minus 2j. This one is done with the idea that I want to present this form, and that's it. So I have this as FQ2. So this is FQ2 Q2. Alright, so you have this. Let's get FQ3. Let's get FQ3. Let's get FQ3, please. Right, FQ3. So, next up, FQ3, that's equal to KQ3 all over RQ3. This one there, all square dot unit vector of RQ3. So you have this. So first of this, is your record? Your record. So record. Alright, let's get RQ3. So we have that RQ3 is equal to RQ minus R3. Alright. Impute this value. Here's my reference. So it becomes 0 minus R3. So here's this. Here's Q3. So I'm moving this way and this way. This way and this way. First of all, this way, this distance is A over 2. In the positive, that's right. So it becomes A over 2I. That's from here to there. Next up, it's coming down this way. That's the negative of J. That becomes minus A over 2J. This one here, of course, all in meters. So I have this. What this is now equal to minus comes here. Minus A over 2I minus minus plus A over 2J, all in meters. This gives you RQ3. This is RQ3, so I have this. Next up, let's take magnitude. The magnitude of RQ3 is equal to the square root of this one minus A over 2 all square plus this one A over 2 all square. We know this answer already, so don't stress. I have that RQ3 is equal to what there? A over what? Root 2 all in meters. So the same A over root 2. You solve this one, you have the same thing in meters. Let's now get unit vector. So the unit vector of RQ3 is equal to position vector of RQ3 all over magnitude of RQ3. And that's equal to the position vector is this one here, minus A all over 2I. Next up, plus A all over 2J all in meters. This one there, all over. The magnitude of this is this. That becomes A all over root 2 all in meters. This will cancel this, so it's up. It's up. Okay, so work on this. This is now equal to, we said factorize, please, I've said factorize just A over 2. Leave out the minus for the I and J. So if I factor out A over 2, it becomes A over 2 into, I'm left with minus I. So minus I, then next up plus J. So plus J. All over, I'm having this A all over root 2. We know what this will give us, okay? That's what that root 2 over 2. Right. So I have that the unit vector of RQ3 is equal to root 2 all over 2 into what there? Minus I plus J. So we have this. We have this. Alright, next up, substituting. Substituting. What do I get? I'll get that FQ3 is equal to the same KQ. So So I'm having KQ into Q3. Please check. What's Q3? Becomes 6Q. That's 6Q. Okay. All over magnitude of RQ3, magnitude. Where is it? This one here. Please see this. Magnitude is A by 2. So A all over root 2. All squared. Set square there. Dot unit vector. That's this. That becomes root 2 all over 2 into minus I plus J. So work this man out. It's now equal to 6 comes out here. That gives you 6 into KQQ all over. Here is square. So it becomes A squared all over. Square cancel square root gives you 2. So I have this. Okay? Dot root 2 all over 2 into minus I plus J. So I have this. Obviously 2 there, 1, 2 there, 3. So I have this. Oh, look up. Listen up. Oh, don't worry. Same thing. But listen. Here was the idea, look up. Here was the idea. We know that these 2 come here, okay? So that 2 cancel 2. But don't worry. Right. Get this done. So that's how equal to. Look up. That's how equal to. We said this one would come here. So become 2 times all of this. 2 times 3 is 6 times this. That gives you 6KQQ all over A squared dot root 2 into minus I plus J. And that's now equal to, we said, just to retain the form, you know what to do. So it becomes FQ3 equal to, just to retain the form, bring this man here, take this one here. That now becomes, this one comes here, becomes root 2KQQ all over A squared into 6 goes this way here. 6 comes here, so 6 into this gives you minus this and this 6I, this and this plus 6J. So I have this. So this becomes FQ3. I have this. Alright, let's get FQ4. Next up, FQ4. That's equal to KQ4 all over RQ4. We have this. All square dot unit vector of RQ4. Get position vector. Position vector of RQ4 is equal to RQ minus R4. This becomes 0 minus R4 from here to this point. That becomes go to X and then Y. So I'm going to negative X. Here to here is A over 2. So it becomes minus A over 2I. From here coming down becomes minus A over 2J all in meter. If I work this out here, minus to this becomes positive. So I'm having A over 2I minus positive plus A over 2J all in meters. Here becomes position vector of RQ4. Get magnitude. The magnitude of RQ4 we said is equal to the square root of this square. So A over 2 all square plus A over 2 all squared. At the end, we know that this is for Q and 4 is equal to A all over root 2 in meters. Let's get the unit vector. Unit vector of RQ4 is equal to position vector of RQ4 all over the magnitude of RQ4. And that's equal to position vector is this one here. A over 2I plus this one here. A over 2J all in meters all over A over root 2, of course, in meters. This cancels the space of factor out A over 2. That's now equal to A over 2 into I plus J all over this one here, A all over root 2. Gives you this. Work out these two here, it gives you root 2 over 2. So that's now equal to position vector of Q and 4 gives you root 2 over 2 into I plus J. Substitute all of this back into your FQ4. So substituting, you have that FQ4 is equal to K into Q. Please, what was Q4 again? 8Q. So 8Q all over this value, magnitude is this, that's A all over root 2 all squared dot unit vector root 2 over 2 into I plus J. Alright, this is now be equal to, I have here as K, Q, Q, 8 comes here, so 8 all over, here gives you A squared all over, square cancels square root, I have 2, that's this, dot root 2 all over 2 into I plus J, so I have it. Depends on how you want to mix it up. This can cancel this to give you 4. So from here, FQ4 is equal to, we said, this one comes here, becomes 2 times all of this. 2 times 4 is 8. So 8KQQ. I'm having 8KQQ all over A squared dot root 2 into I plus J. Do your switching. So this one comes here, becomes root 2 into KQQ all over A squared dot 8 goes here, becomes 8I plus 8J. I have this. So finally we've gotten FQ4. So to get FQ resultant, let's now add up all our answers. Add up all our answers for FQ1, FQ2, FQ3, and FQ4. Add up everything. It's now. These 2 comes here. This 4 now, but these 2 comes here. That is 8. So let's now get FQ resultant. We have that FQ resultant. We said it's equal to FQ1. So FQ1 plus FQ2 plus FQ3 plus FQ4. Please help me recall. What's FQ1? Recall FQ1. Root 2 KQQ all over A squared into, what do you have? I minus J. Okay. Give me FQ to this. Root 2 KQQ all over a squared into what? Minus 2i minus 2j. Okay? Give me f q3 root 2k q all over a squared into what do you have? Minus 6i plus 6j. Okay? Plus one final one, fq4 root 2k q all over a squared into 8i plus 8j. If you look at what we have here, look at this. Look at what we have here. Look at what we have here. What's common here is root 2k q over a squared. It's common here, 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 here. So factor it out. If I factor it out, it becomes equal to root 2k q all over a squared. What do you have here? I minus j. What do you have here? Minus 2i minus 2j, yeah? Minus I plus 6j plus 8i plus 8j. So I have this. So work them out. That's now equal to, that is f q resultant is now equal to root 2 k q all over a squared into I minus 2i minus I minus 6i minus 7i plus 8i I. That's 1i, which is what? 2i. What with j? Minus j minus 2j minus 3j plus 6j plus 3j plus 8j plus 11j. So plus 11j. Problem. So that's right. B-part says find the numerical value of the net force FQR if Q. They said if Q, so given if Q is equal to 2 microcoulomb and capital Q is equal to 4 microcoulomb and A is equal to 5 meters. Please help me recall FQR. FQR is equal to root 2 KQQ all over A squared into I plus 11J. Please substitute value. That's now equal to root 2 into K. K is 9 times 10 to the power 9 into Q. This Q is this 2 micro. 2 times 10 to the power what there? Minus 6 into capital Q 4 micro. 4 times 10 to the power minus 6. Please punch all of numerator. All over A squared, that's 5 squared into I plus 11J. Please give me all of numerator. Give me like 4 dp. What do you get? All of numerator in 4 dp. What do you get? You got what there? 0.1018. This all over 5 squared is what? 25 into I plus 11J. Please give me this one here. What do you have? This one here. 0.004072. I'm close with how many? 3. 3 into I plus 11J. This is 0.004073I plus, please multiply by 11. What do you get? 0.04 0.48. So let's say 8J, Abby. All in Newton. These decimals are too long. Let's approximate it. So I have that FQR, the numerical value of FQR is equal to, I'm using 0.1234 in 4 decimal places, 0041I plus 4 decimal here, 0.0448J, all in one there, Newton. So we have this. So this becomes the numerical value of FQR. So this is how you solve this question.